Okay, welcome back, everybody. For our next talk, we've got Peter from Amazon Web Services. Peter's going to be talking about building a CAPI provider for Apache CloudStack. I'm super excited to hear this talk. I'm super excited that Peter is here to do this talk. I've had some personal involvement in this project as well, and it's been brilliant seeing it develop. And we're sort of finally there now, and here Peter is to tell us about, I think, one of the most significant bits of integration we've had for CloudStack for a number of years. So Peter, welcome. Over to you.
Thank you very much, Giles. It's a pleasure to be here. I appreciate the invitation. So as Giles mentioned, I'm Peter Matkowski. I'm a software development manager with the customer engineering team at Amazon Web Services. Bit of context on what that team is. We're part of AWS Professional Services. So we build out pieces of software that our customers are distinctly asking for. And this CAPI provider falls into that category. So let's talk a little bit about what is CAPI and what is this provider specifically. So before we get there though, thanks for our esteemed sponsors here. Let's talk about CAPI, also known as Cluster API. So Cluster API is a set of Kubernetes constructs for allowing folks to provide declarative APIs for provisioning, upgrading, and operating multiple Kubernetes clusters at scale. So what exactly does that mean? Well, it provides a framework so that one could implement an arbitrary infrastructure provider to deploy Kubernetes clusters to any type of infrastructure. And as you might imagine here, what we're talking about in terms of deploying Kubernetes clusters, we're talking about deploying them to CloudStack. So the Cluster API has amazing documentation. So let's head over to that documentation briefly to look at a figure that talks about this in a bit more detail. So this figure that I have up on my screen is part of the Cluster API book. And you can see that we have a whole suite of constructs that have been put in place to realize the Cluster API. And the parts that we're most concerned with here is this bottom tier, which is you can see all of these abstractions allow for deploying Kubernetes clusters to all different types of infrastructure providers here. We have AWS, we have Google Cloud, we have VMware, and use your imagination, you could insert Apache CloudStack here with the provider that we have built. If you look at the provider list that is illustrated in the Cluster API book, you can see here's the current list of Cluster API providers that exist. I look forward to this list being extended with Apache CloudStack. All right, so with that context, let's talk a little bit more about CAPC, which is the Cluster API provider for CloudStack, also known as CAPC. So what this is the infrastructure provider implemented to be able to deploy all of the resources necessary to Apache CloudStack to realize a Kubernetes cluster. And the way that this is implemented is it's using the CloudStack Go client so that the provider, when deployed, is able to take action against a CloudStack instance to deploy virtual machines as necessary, networks, and all of the respective resources necessary to realize that cluster. So it's taking advantage of that CloudStack Go client. We developed this project as open source, so it's out in the AWS GitHub. I'll go ahead and head over there in a moment to take a quick look there. And we're in the process of donating this code base to the Kubernetes SIG, which is the parent organization that most of the other CAPI providers I had referenced there in the book are housed. So it's the typical landing zone for a mature, ready-to-use CAPI provider. And ultimately, what this provider enables deploying Kubernetes clusters to CloudStack, and it's quite a great piece of software. We'll do a demo here in a moment after I give you a quick look around the code. So as I mentioned, it's developed as open source. So you can head out to GitHub and you can see it presently housed at the AWS org at Cluster API provider CloudStack. And you can see all the active development that has been going on. And as I mentioned, it's ultimately being migrated over to the Kubernetes SIG, which you can see we have our outstanding request to migrate this repository. We're going through all of the motions necessary for the organization to accept this donation. And we foresee that happening here in the near future, moving out of the AWS org and into the Kubernetes SIG GitHub org. All right, so let's talk about what actually goes on with this piece of software. So we're going to go ahead and illustrate creating a cluster. And what you start with to create your cluster is you start with an Apache CloudStack deployment and some arbitrary Kubernetes management infrastructure. And that could be any Kubernetes management infrastructure. For the demo that I'll be doing, I'll be using a local Docker installation. So you can see I've got Docker running here on my computer, and I'm going to go ahead and use that as my Kubernetes management infrastructure. But use your imagination. This could be any other Kubernetes system that you use for managing the Apache CloudStack infra. So the first step of it is initializing that Kubernetes management infrastructure to create what's called a Bootstrap cluster. And that Bootstrap cluster is what will house the CAPC provider and ultimately take action against Apache CloudStack to deploy the necessary virtual machines to support the requested cluster. And that is done by using a command line utility that's provided as part of Cluster API, which is cluster cuddle. So you can see here's the command line that you would use to plumb your Bootstrap cluster cuddle init, expressing the infrastructure type of CloudStack. All right. The next step is you need to generate your manifest file. This manifest file is a standard Kubernetes construct. It's how you describe your cluster. How many nodes do I want in terms of a control plane and a worker set? And that's just a file generation that emits YAML that describes that cluster. So again, using cluster cuddle, we generate that descriptor and we output it to a YAML file. And now we have our file that is ready to go. I depict this as a step because you can then take that manifest file, modify it as you see fit, express different configuration options before you would go ahead and apply it to your Bootstrap cluster. So the next step is you take that manifest file, you apply it to your Bootstrap cluster. That's where we bring in our familiar friend, kubectl, which is a tool we might be a little bit more familiar with as opposed to cluster cuddle. And we apply that spec file or that manifest file against that Bootstrap cluster. At that point, CAPC kicks in and it sees that it has been requested to take action on creating a cluster, which at that point we have our custom resources that have been defined, and now CAPC springs into action deploying the respective VMs. So in this illustration, I'm depicting 3 VMs. Imagine one of them being a Kubernetes control plane and 2 of them being Kubernetes worker nodes. So CAPC will provision those virtual machines. And then when those virtual machines enter a ready state, we can then start applying the Kubernetes software to those nodes. So then the Kubernetes bits have been laid down on the respective VMs, and they're ready to become a Kubernetes cluster. So at that point, they start self-organizing into that cluster, and the ultimate end state is a cluster that is ready to have a workload deployed to it. So I'm going to go ahead and demo this. And the workload that I'll deploy to this cluster, just to show it in action, will be an Nginx workload, just a basic, Nginx hello page showing that we can deploy a workload to it. All right, let's go ahead and hop into a demo. I'll adjust my font briefly here. And I'm going to go ahead and start with the steps on getting our Bootstrap cluster created. And I'll go ahead and I'll swap back to the illustrated figure as I'm carrying out these steps, so we can kind of tie back each one of them to the respective pieces of that diagram. So I'm going to go ahead and clean up my existing management cluster for now, just to have a blank slate to work from. And I mentioned I'm using my local Docker installation on my computer as my management cluster. And to facilitate that, I'm using a tool called Kind, which is Kubernetes and Docker. It gives me a Kubernetes environment locally that can act as my management cluster. So while this is preparing, I'll go ahead and hop into the chat here and see if there's any questions. Oh, I saw about making my slides full screen. Sorry about that. I was swapping between windows. I felt it would be easiest with it out being full screen. But if there's any other questions as I go here, feel free to throw them into the chat as we go. If any of the steps are unclear, or if you'd like a little bit more detail as to what's going on as each step is carried out. All right, so our management cluster is being created. So as part of the journey, we are here basically creating this Kubernetes management infrastructure. All right, we have our Kubernetes management infrastructure. So the next step we're going to go ahead and carry out is we're going to carry out this preparation of the Bootstrap cluster. So let's go ahead and get the necessary commands for that piece. And we'll then watch the cluster get created so we can see all the bits getting laid down inside of that management cluster. Oh, sorry about that. I forgot to set an environment variable. One moment. Part of the setup steps is to set your credentials that you would expect needed to talk to the CloudStack API. So now that I've got that set as an environment variable, I will go ahead and begin preparing my cluster. All right, we'll see a bunch of output emitted as it's installing the respective components into the Bootstrap cluster. Once I return back to a command line, I'll run a Kubernetes command that can help see the state of the system as it's becoming ready for use. All right, so I'm going to go ahead and watch the output of Kubernetes kubectl get pods. And we can see that we've got the CAPC controller and other CAPI components that are becoming available. And now they are in a ready state and they are running. So we are now at this state of the depiction of the journey where we have our CAPC provider ready within our Bootstrap cluster and we're ready to go. All right. I see one question from Renee. I will save that for the end. I'll get into that topic. All right, so next step is we're going to prepare our cluster manifest. And go ahead and exit out of my watch command. And prior to generating our manifest, I need to set a variety of environment variables that express some of the characteristics of my cluster and my CloudStack infrastructure. For example, what's my endpoint, my port, the name of my cluster, how many machines I want, how many workers control plane machines, and how many workers, and my Kubernetes version. So a lot of different environment variables that go into the expression of the manifest. So now that I have those set, I can go ahead and generate my manifest. Again, using cluster-ctl. So we're at this step here of the journey where we've gone ahead and used cluster-ctl generate, and we have generated our manifest. Let's go ahead and take a quick look at that manifest. It's a large YAML file, so we're not going to go through it in like exhaustive detail, but just to kind of hone in on a couple of the points that you can see. We have the CloudStack cluster kind defined here. We have our cluster name. There's our control plane endpoint that will be requested of the infrastructure, and then which network are we going to use, which zone, all the different details necessary to take action against our CloudStack infrastructure. All right. Well, we're at the point where we are ready to apply this manifest to our Bootstrap cluster, which then will trigger CAPC to take action and start deploying the respective virtualization resources to Apache CloudStack. So I'm going to go ahead and run the kubectl command, and then again use watch to watch the cluster be created. All right, so we've returned to our command prompt pretty quickly because everything's happening asynchronously in the background as the reconciliation loop with the Kubernetes engine kicks in. And I'm going to zoom out a little bit for the formatting of this command. And we can see now that we are now taking action against our CloudStack infrastructure. So let's head over to CloudStack and see what we've got going on. Oops. Let me go ahead and relog in. All right, so you can see we have machines now that are being created within CloudStack that correspond to the cluster that we see here on the screen. So you can see we have the CAPC cluster control plane, and we have an identifier on the far right-hand side of it, which is D8T8K. And if I were to mouse over this piece of infrastructure, you can see that it corresponds. Oh, curious. Usually the names are quite aligned there. All right, yes, I seem to have a bad state here. So I'm going to go ahead and clean up a little bit and start over if we don't mind. I believe these not lining up with the naming that I had anticipated is the root cause here. So one moment, I'll clean up and give it another go. Okay, so I'm just cleaning up these two, and then we'll go ahead and clean up a little bit more and give it another go. And this time I'm going to go ahead and use my quick start script, which has the steps all orchestrated as a single command to avoid another mishap. I'm just going to wait for this unit to expunge, and then I'll go ahead and kick off that quick start. I do see the question on which version of ACS is supported. So we have 4.14 here, which is what I'm using, but we're also working with 4.16 for testing as well. And for Kubernetes, we support 120 and 121. All right, so we've cleaned those two up, and I'm going to go ahead and use my quick start script that I had mentioned is got these steps a bit more tightly orchestrated. So it's going to go ahead and delete the cluster or the Bootstrap cluster and recreate it. Apologies for the redo here. While this is going, any other questions, feel free to put them in the chat.
Peter, there's quite a few questions coming in on the QA pane as well. I don't know if you've seen that one.
Oh,
QA.
thank you. Okay, I see what's the benefit of using CAPC instead of CloudStack Kubernetes service. They're different in nature. CAPC is implemented against the cluster API, which is a rather popular abstraction standard for creating clusters against arbitrary infrastructure. So I'd say they're just different approaches to creating Kubernetes resources within CloudStack. I see that was two questions on that. Okay. How far is this integration has completed compared to others? Any interesting performance things you have observed with CloudStack compared to others? As far as how complete it is, we've completed all the lifecycle events that are part of CAPI, creating clusters, upgrading clusters, deleting clusters. So there's all the lifecycle events that are part of the cluster API, and those have all been implemented and are rather mature. As you can see, that development carried out in GitHub. Okay, so we're waiting here for our Bootstrap cluster to become available. What's the advantage of deploying a cluster to the target? Gregor, your question about having the management cluster. So having the management cluster allows you to do things like rolling upgrades and the types of cluster lifecycle events where you need an external entity to orchestrate events. That way you can do zero downtime upgrades, and that way manage the Kubernetes cluster from an external resource, so it's not managing itself and therefore needing to have downtime for upgrades. Okay, so our Kubernetes management cluster is ready. I'm going to go ahead and exit here and allow it to continue. All right, so now we have our machine deploys taking place. Our control plane machine deploys taking place. Let's go ahead into CloudStack and see that reflected. WC4BM, WC4BM. Okay, IDs match now. Again, pardon for the redo here. So this is the virtual machine that's being created that corresponds to this Kubernetes control plane. It's coming up and coming online. Our virtual machine names match, so we've got the right things taking place now. And then our worker is getting deployed, which will have the ID of the DVX5S. So we'll see that show up here in a moment. All right, so we have got our machines ready here. Everything is in the true state with the exception of our workload cluster, which it is simply waiting to have its networking stack applied to it. So if I refresh here, we should see now I have my control plane virtual machine, WCB4, and then there's the worker, the DVX5S, and that corresponds to those two pieces of output. All right, now the Cilium network stack is going to be applied to it. And at this point, we reach this phase of our deployment, where our workload cluster is ready for deployment. So let's head back to the command line, and Cilium's being applied. And then I'm going to deploy Nginx and see our Kubernetes cluster ready to serve traffic. Just checking in on all the other questions and make sure there's no other. All right, here we are with our cluster, everything ready in a true state. We can deploy a workload to it. So I'll go ahead and bump my font back up since I'm not going to use that output any longer. That has the ASCII table. All right, so I have a web app YAML. It's just a simple Nginx container, and I'm going to expose it on port 30,100. So let's go ahead and apply this to our cluster. We're going to use the kubeconfig that was generated by the quick start. And we've got our pod of Nginx created and our service. Let's go ahead and kind of interrogate the cluster just to see the state of things and their readiness for use. Okay, it's creating the Nginx container in the background. It's pulling down the image, getting that container ready to run. All right, it is running. Let's check out the status of the services, make sure they're all ready. All right, looks good. There's our port 30,100. And let's head over to, there we are. We have Nginx running on the Kubernetes cluster that was deployed to Apache CloudStack via the CAPI provider for CloudStack. That's the full loop of the deployment. All right, so thank you very much. I'm super excited to get a chance to show that to you. I apologize for having to do a second try at it, but the second try is a charm. I'm going to go ahead and scan through the questions. I see Damon had asked, does the management cluster have to be a kind cluster, or does this type of cluster actually matter? No, kind was simply used here as a convenience for having it on my local workstation. But no, you can have another Kubernetes cluster that could be long-lived and could act as your management cluster for creating, maintaining, upgrading your clusters. So kind was just a convenience for demonstration purposes. I'm gonna go ahead and pop into the chat. All right, I think I've touched on all the questions in the Q&A in the chat. Again, thank you very much for the opportunity to come talk to you. Super excited about this project. It's been a lot of fun to collaborate with the CloudStack community on understanding how CloudStack works, how to use the APIs to drive the infrastructure creation, and deliver another way to run Kubernetes workloads on CloudStack.
Peter, thank you very much. Really good, and nice to see the demo gods finally got behind you at the end there. It'd be great to see you and some of your colleagues in our community going forward. Hopefully we'll see some Amazon email aliases in there. And thank you very much for this contribution. I think there's a lot of people very excited about this. So thank you, Peter.
Appreciate it. Thanks.